So what we're talking about today is being able to test the hypothesis about proportions. And so now we're going to start combining a lot of the different things that we've been learning about proportions and means together. And we're going to start off by focusing with proportions. Whenever we come up with any kind of test where we're trying to see if there was actually a difference in a percent or proportion, what we have to do is we have to state the null and the alternative hypothesis. The null hypothesis specifies a population parameter of interest and proposes a value. You got to kind of think about it as the who and what. You got to describe who are we talking about and what are we looking for. When we write the null hypothesis, it's always equal to. And what happens with here is that nothing changes. We are trying to see if something changes, but your null hypothesis is as if nothing changes. Okay, and so it's your HO, your H sub O, and the parameter equals your hypothesis value. Okay, so let's say on our test or our quizzes, the average percent of people that pass a test or quiz with a D or higher on the first time going is 72%. So I'm going to say that the passing percent is 72%. So I have to explain what I'm doing, and then I have to write my expression. So my proportion is 72% of the time. Now what we're going to try and find out is if we've done different things. Maybe I've been teaching stats differently, or have the grades gone up since we've done notes in our notebook. There's a kind of different things, but to test to see whether things have changed, you also need to have an alternate hypothesis. Okay, so there's two types of alternative hypothesis. There's a two-sided, which means it can go in either way of the mean, so I can be an increase or a decrease. Or there's a one-sided, which is only one. So for a two-sided, when you have a two-sided, you're looking for any kind of change. It's not specific, it's just meaning that there was some kind of change. For a one-sided, it's particular, okay? It either wants an increase or it's going to ask if there was a decrease. Okay. All right, so the HA alternative, again, is the parameter, but this time there's change. Well, that means that it's not going to equal the hypothesis value. And so going back to our problem with our test average, or our test, the percent of people that pass the test the first time. So passing percent is not 72%. And so P is not 0.72. And so that would be the alternative. If I wanted a one-sided thing is still the same thing. It's the parameter and the hypothesis value. Parameter and the hypothesis value. But let's say for my problem, I'm trying to see if there was an increase. So, was there an increase? Passing percent increased. So that means my P is going to be greater than 0.72. If I was looking for a decrease, it would be less than 0.72, but I don't think I'd be looking for a decrease in the percent of people that pass a test. All right, so before we talk about p-value, we're going to actually do some more null and alternative hypothesis just to practice. Okay, so here's our problem. Make sure you copy it down so that you're able to have it. 80% of students attend advisory. To raise this percent, the school starts giving prizes at random for those students that attend advisory. Has the percent increased? So we would need more information to run the full test, but all we're looking to do is we're looking to write our HO and our HA. And remember, our HO is our null. It's like H0, and null is nothing. Okay, so advisory attendance is supposed to stay the same for the null, so it's going to be 80%. And so your P is 0.80. The alternative, we're looking for an increase. So advisory attendance has increased. So this time it's going to be greater than 0.80. Okay. And so again, your null hypothesis is it stays the same, and your alternative hypothesis is that it has changed. If it's changed, it's a not equal to sign. If it's less than or it's decreased, it's a less than sign. And if it's increased, it's a greater than sign. Okay, last one, same thing. I'd like you to go ahead and see if you can write your null hypothesis and your alternative hypothesis. So your null hypothesis is that it stayed the same. So 85% of high school students use Facebook. So that's going to be P equals 0.85. So the second one says, has it changed? It's not saying an increase or decrease. So it's not 85% of students have used Facebook, high school students use Facebook. Percent of students, percent of high school students that use Facebook is not 85%. So it's not telling you if it's an increase or decrease, it's just saying not. And so that means my P does not equal 85. Okay. And so that's all we had to do for our null and our alternative hypothesis. Remember, your null stays the same, and it's your alternative that you change.